Chapter 3. The mean value theorem and Rolle's theorem. The mean value theorem. If y equals f of x, and in this sketch I have y equals f of x right here, is continuous on AB, that would be your domain, and differentiable on the open interval AB, which means that your function is smooth and continuous, then there is at least, there can be more, but there's at least one value c, and that's an x value, in the interval AB at which the slope of the secant, which is right here, that's your secant line, that slope is the same as the slope of the tangent. And there's your tangent line at C. So that means that the average rate of change and the instantaneous rate of change are the same. The formula for it is right here. This is the slope of the tangent line at C, and this is the slope of the secant line on AB. So you have a formula for it to the left, and then you have a visual that shows you geometrically what it means to the right. Okay. Now, remember that the definition said at least one c, such that the slope, instantaneous rate of change, is equal to the average rate of change. Now let's see if we can sketch any function. We don't need the equation, just a sketch where the tangent line is parallel to the secant line more than one time. Okay, so why don't you try to do it, and I will attempt it here. We'll see what we have. Let me start over. Okay. There's my secant line. Now, here's a c value. Here's the first one that's parallel. So it would have the same slope as the average. Here's another one right here. Here's yet another one. Oops, what happened? Here's another one right here. And then it looks like yet another one under here. So it didn't line up exactly, but you can see that it looks like I have 4 c values where the slope at each of those c values is the same as the slope of the secant, which is in red. Now we're going to do this algebraically. So here we have a function f of x equals x squared plus 2x minus 1, and we want to know at what x values on the interval -2, 3, notice it's closed, does the graph satisfy the mean value theorem? Well, first of all, it has to be continuous on that interval, and since this is a parabola, it is, and it has to be smooth, and it is. So we know that it satisfies the requirements for the mean value theorem. Now we need to find the x values. I think on the next slide I have a graph. So let's just go through this. Hold on. Yeah, let's look at this graph first, and then we'll go back. All right, find -2, 3 on the graph and plot the point. So there's -2, and there's that y value. And then at 3, here's approximately that y value. Now let's draw the secant line through those 2 points. Remember, that gives you the average rate of change. Okay. Now, geometrically, remember there's a c value that has the same slope, and that c is an x. So before we find it, let's see if we can draw the same slope on the curve, which would be the tangent line. I missed it. Let me try again. Okay, there it is. So it looks like it's x equals 1/2. Alright, so let's go back and do the algebra with this. So we know that it follows all the requirements. We talked about that. And we're going to find our derivative, because the derivative gives you the instantaneous rate of change. Using the points -2, -1, 3, 14, which I found by plugging in to that function, I find the slope of the secant is 3. So then I set my derivative. This is f prime of x equal to slope of secant. And then I solve and I get x equals 1/2. Alright, now I'm going to write out some steps for that. I just kind of did a little preview. So the steps would be, number 1, find the slope of the secant. Or average rate of change. So the slope of the secant would be 14 minus -1 over 3 minus -2 is 15 over 5, which is equal to 3. That's right here. Okay. Number 2, find the derivative. That's done for us over to the left, and the derivative is f prime of x equals 2x plus 2. Number 3, set the derivative equal to slope of secant and solve. Because you're finding the slope of the secant, then you want to know what x value on the slope of my tangent line has the same slope. Then, after you solve, you'll have the instantaneous rate of change at x equals 1/2 is the same as the average rate of change. And you can check that out. If you check it out, you plug in f prime of 1/2 is equal to 2 times 1/2 plus 2 equals 3. Check, check. Okay? Alright. And there's our graph. We thought it was 1/2, but you never can be sure. Okay, now, Rolle's theorem. Rolle's theorem is really not as strong as the mean value theorem, but still very useful. Rolle says that f still needs to be continuous on a closed interval and differentiable on the open interval. But the difference, he says, that if you know your y values are the same for a and b, so that is a y value and that's a y value at a and b respectively, then there is at least one number in c such that the slope of the tangent line is 0. I think I need to bring it, whoops, let me go back. And it didn't really come out, so let's write it here, such that slope of tangent line equals 0. I don't know what happened to that line. So it's kind of the same thing as mean value theorem. It's just talking about slopes of the tangent line. So you would have a turning point, in other words. And there's a visual of it right here. Let's do an example of that. Find two x-intercepts such that f prime of x equals 0 at some point between the two x-intercepts. Let's go to the visual first. I think that always helps. Okay, here's the visual for that, and it's saying if f of x equals x squared plus 3x minus 10, then we need to find some value such that on this curve, such that the y values are the same. Now I said x-intercepts because that's the easiest way to do it. Because if you can find your x-intercepts, you know the slope there is 0. And then you can find the slope right here. So when we go back to the slide before this, we're going to find our x-intercepts, but because we know the y value at those x-intercepts are the same, they're equal to 0, and then we can use that to find this x value here, right here, which is a turning point. Now, you could use any horizontal line on this curve that you wanted to. You could come up here and find those two x values. It wouldn't matter. I'm just saying the x-intercepts are a lot easier to find. So let's go back and take a look at this. So here's my function right here, and I set it equal to 0, and I found my two x-intercepts. And at these two x-intercepts, the y values are the same. They're equal to 0. Then over here, I took my function, and I found my derivative, and then I set it equal to 0. And I solved, and I found that this is the c value, where x is equal to negative 3/2. It has a slope of 0. I hope this makes sense. Okay, there's the visual again. Alright, on this slide it says explain why Rolle's theorem does not apply on the interval 1 to 7. Well, here's 1, and here's 7. Why does Rolle's theorem not apply? Well, remember it has to be continuous on the closed interval, which this is continuous, and it has to be differentiable. Okay, there's our problem right here. It's not differentiable there. It looks like 4, because the derivative from the left does not equal the derivative from the right. So therefore you cannot use Rolle's theorem, nor could you use mean value theorem. They both say it has to be continuous and differentiable. There, you can just read that. It's kind of a summary.